hoping, I'm just keeping my fingers so crossed that you guys can do this problem right here. If I asked you to add 2 sevenths plus 4 sevenths. Oh, come on.
This is just some background work. It amazes me to no end how much of a struggle fractions are to some high school students when this is an elementary school topic.
This the answer? Are you sure?
Yeah.
All right, what's the answer then?
6 sevenths.
Now, why were we able to add those fractions together?
Same denominator. You guys know that, right? I hope all of you that have made it through elementary school successfully should know that you have to have a common denominator to add fractions. But when you do have a common denominator, you don't add the denominators.
You add the numerators.
So that was a pretty easy one. What about this one? If I asked you to add 2/3 plus 1/5. Multiply. Keep going. Multiply that by 5. Okay, was that it? Could be in the top as well. Now, I've been teaching a long time. I've seen a lot of weird things. This is the correct way to do this problem. I've seen this on a number of occasions. I see that actually all the time.
Why doesn't that work? Doesn't that give us a 5 in the denominator?
Yeah. Can anybody explain to me why? This is wrong. This is way wrong. This is not even close. This is nowhere close to being right.
Exactly. If we did this, we would end up with 4/5, right?
Yeah.
Is 4/5 the same as 2/3? Are they the same fraction? No. I've changed the value of that. You cannot add something to a fraction. That doesn't work. Why then does this work?
We're keeping it the same ratio. The numbers change, but what is 5 divided by 5 over here? Just 1. All I'm doing is taking 2/3 and multiplying it by 1. It doesn't change 2/3. It changes the form of the fraction
Into an unsimplified form, but it doesn't change the actual fraction.
And over here you do the same thing. You multiply it by 1, basically. 3/3 is just 1. So you end up with 10/15 plus 3/15. And you get 13/15. Adding fractions is like adding like terms. And in this case, the like terms means they have to have the same denominator. If they don't have the same denominator, they're not like terms. 10/15 plus 3/15 is 13/15. Well, there's your lesson. We're done.
No. The only difference, though, is going to be these are going to have some variables. Instead of a 7, it might have a 7x or a 7y.
Just different things like that. So on page 162.
It starts off so easy, it's embarrassing how easy these problems start. But do you see on page 162 where it says problem number 1? And then it says, got it? Write that problem down. Middle of page 162, problem 1, where it says, got it?
Try the problem if you can. If not, just write it down and we'll talk about it here in a second. But if you think you can try it, then try it.
Oh, this problem's so easy, it's embarrassing.
Already have the same denominators, don't we?
They already have a common denominator. So,
What that means is these two fractions can be added together, and your denominator in the answer is going to be the same 3a minus 4. It doesn't change. You don't add the denominators together.
Yeah, the numerators.
3a and 2a makes 5a.
So I want you guys to do this one on your own.
Do, where is it? Underneath problem 1 where it says practice. You see where it says practice?
We're looking at the right one here. Yeah, do this problem here. Real quick. It should take you like 10 seconds.
This is problem number 1 where it says practice
In your book.
Give it your best attempt. And then turn to the person behind you or in front of you or beside you. Talk about what you got.
Do we at least all agree that it's 2c plus 7 on the bottom?
Yep.
Now what about the numerators? That's c is 1. See, if you have 5 c's and you add another c,
That makes 6c.
okay, you're adding like terms. 5c plus 1c is 6c minus 28.
Is there any real difference between adding two fractions and subtracting two fractions? Not much difference at all.
So see what you can make of this one here. This is on your page. I think it's
It's the same page.
Do you have problem 2 on that page? Or is it on the next page?
look at problem 2. Don't you guys have this problem somewhere? B on problem. All right, let's do part B on problem 2. This one here.
What's that? Oh, problem 2? Give this one your best effort. Example 2, part B here.
Do the same thing real quick. I'll give you 10 seconds because we gotta really speed this up. Turn to your partner, person behind you, somebody, discuss what you have.
Well, you subtract that positive 5, so it's still taking
6n. Let's talk about each piece of it. We know the denominator is going to be 10n minus 4. Is there any discussion on the denominator? 10n minus 4. I heard a few different things going on relating to the numerators. Let's be clear on the numerators here. 9n minus 3n is 6n. So we're going to have a 6n.
And then we have 10n minus 4 down here. 6n minus 8. 6n minus 8. And why minus 8? Well, it's this minus sign right here. You're not just subtracting 3n. This minus sign has to distribute to both of those. You're really subtracting 5.
You're not adding 5, you're subtracting 5. You guys follow?
So this is negative 3 minus 5. What is negative 3 minus 5? Negative 8.
No. That answer is wrong.
Or at least it's not fully simplified. Can you guys see what I'm talking about?
Isn't there a common factor in the numerator that you can factor out? If you factor out a 2 from the numerator, you're left with 3n minus 4. What can you factor out of the denominator? Another 2. That leaves you with 5n minus 2. Well, what was the whole use of that? 2's are gone. See you later, 2's. That would be the simplified form of the answer.
3n minus 4 over 5n minus 2. Okay, I want you guys to do problem 3. You see a problem 3? It's still underneath. No, hold on. It's on page 163 at the very bottom. It says A practice, and then it says a little problem 3 about it. What's example? Okay. Yeah, yeah. Go to the bottom of page 163 and try problem 3.
In a lot of cases, that's true. Dang, I had that paused the whole time. Oh, well. Well, the answer's 2 for that one. All right. Go to
The next page of your book, page 164. Now, at the very top, doesn't it say problem 3? Yeah. Let's make this example 3 now. And then I want you to do the got it problem. Or at least write it down. We need to talk about this one. Where it says problem 3, got it?
On page 164, at the very top.
All right, now we have a problem. We don't have a common denominator. And it's not just numbers we're dealing with. It's numbers and variables and exponents and everything else that's awesome. So let's just deal with one thing at a time. The coefficients. We have a 7. We have a 3. What's the common denominator? If it was just a 7 and a 3, the common denominator would be 21. So let's at least start by making the numbers the same, the coefficients.
This side's going to need a 3 over 3. This side's going to need a 7 over 7.
That takes care of the coefficients, but now we have to make sure we have the same exact number of variables.
The left side is y to the 4th. That means there's 4 y's. Y times y times y times y. Over here, go ahead 2, y squared. That's an easy fix. How many more y's does the left side need so that it has as many as the right side? Or that's not that backwards. How many more does the right side need so it has as many as the left side? Needs 2 more.
So what's that going to look like?
Y squared over y squared.
Okay.
So now I'm going to change these fractions. Now we have 9 over 21y to the 4th plus 14y squared over 21y to the 4th.
That was really easy to get common denominators in that problem. Really easy.
So when we add these two fractions together now, we're going to have 21y to the 4th in the denominator.
What about the numerator?
14y squared plus 9. Those are not like terms, so they cannot be combined.
Now please, please, please listen closely to this next part. This 14y squared plus 9, because there's a plus 9, or a plus sign rather, that connects the 14y squared and the 9 together as one factor. You don't have to put it in parentheses, but it's nice to think that this would be inside of a parenthesis. That means you cannot just cross off bits and pieces of what's inside of here. You understand what I'm saying? Because what I was wanting to ask is, what about canceling some of these y's here with some of those y's there? Is that going to work? No. If this plus 9 weren't there, then could we do that? Absolutely. Okay, but that plus 9 that we just had there means that 14y squared plus 9 has to stay together as 14y squared plus 9. Now, if there were a common factor, you could factor that out. Is there, though, 14y squared and plus 9? No common factor. There's nothing we can do to further simplify. That's as far as it goes. Okay? So here's one I want you guys to try. Problem 5.
Same page, problem 5. Now, hold on a second. When I say I want you to do problem 5, it's not problem 5 in the big red highlight. It's, do you see where it says practice A, problem 5?
It's in number 5. These are the problems here.
All right, do number 5.
There we go.
On page 164, do number 5. Start in the middle. Try that one. You know what problem we're working on, Colton? Would this seat right here be better for you?
Nope.
Maybe it's because you were talking to him. We're doing problem 5 on page 164. Try to have more than a 5-second attention span. Please.
Are we getting 20x squared plus 18 all over? 15x to the 8th? 20x squared plus 18 over 15x to the 8th?
So where did that even come from? If we're just looking at the 5 and 3, then the least common denominator, or the greatest common factor there would be 15. We'd have to multiply that by 3. Over here, we multiply that by 5. But now, this right side has only x to the 6. It needs to be x to the 8th. So it needs an x squared over x squared. So we have 18 over 15x to the 8th plus 20x squared over 15x to the 8th. Now you can add them together because they have a common denominator. And you get 20x squared plus 18 all over 15x to the 8th. Now, I guess there is one more thing you could do. It doesn't help, but 20x to the squared plus 18, common factor. But if you factored out that 2, the only reason I would ever factor out something is if you could factor out the same something from the denominator. Does that 2 really make a difference with anything in the denominator? Doesn't really. So I would say this would be unnecessary right here. If you did that, fine. But this would also be completely acceptable. Huh? Alright, we're just about done. We have 2 more problems. These ones are just as easy, but
You got to take a moment to let your head wrap around these ones. Let's do example. Ooh, which one is this?
tell me the flaw in my logic here. Because this is very flawed. This is m plus 2. Wouldn't it be nice if this were also m plus 2? So what if I just added 9? Can I even do that? Because it makes it m plus 2. You can't just add values that are nowhere to a fraction. You can't do it. You can multiply a fraction by something on the top and bottom. Is there anything, though, I could multiply m minus 7 so it looks like m plus 2? So let me just get a blank screen here. If we had 3/5 plus 2/7, what would we do on this problem? You multiply this side by 7 and multiply this side by. So you just multiply each side by what the other side has. You following? Well, over here on this problem, this side has an m plus 2. Is there an m plus 2 over here? So it needs to have an m plus 2. You multiply each side by what the other side has, just like you would with numbers. Okay. But now the right side has an m minus 7 and an m plus 2. So what is the left side missing? The left side is missing an m minus 7. Now aren't both denominators exactly the same? Both denominators are the same, right? So here's how you continue to simplify this. Please watch carefully. The denominators, just leave them in parentheses. M minus 7, m plus 2, plus, and then over here, leave that as m minus 7 times m plus 2. Don't multiply those together in the denominator. Numerators, though, you are going to multiply out. Distribute the 9, distribute the 8. So you're going to have 9m minus 63. Over here, you're going to have 8m plus 16. So can we add these now? How come we can add these now? They have the same denominator, exactly. M minus 7 times x plus 2, the other one has m minus 7. So when we add these together, remember you're only combining terms in the numerator. 9m plus 8m, 17m. Oh crap, negative 63 plus 16. Negative 47. Thank you. All over m minus 7 times m plus 2. So, down at the bottom of page 164, where it says in red, problem number 4, you see that one? In red, do the got it problem, or at least write it down.
We'll make this example 4. Try to get as far as you can on this one.
I know you might not be all the way finished, but man, bell's ringing here pretty soon, so at least make sure you got off to the right start. this right fraction has a c minus 2. Doesn't it, in the denominator? Is there a c minus 2 over here? Well, there has to be. So how do we make a c minus 2? Multiply it by c minus 2 on the top and bottom. But now this left fraction has both a c minus 2 and a 3c minus 1. What's missing over here? 3c minus 1. Now both denominators have the same thing. So if you distribute the c, you're going to have c squared minus 2c. Then here you're going to have c minus 2, 3c minus 1. Over here you're going to have 12c. Where'd that come from? 12c minus 4. 4 times 3 is 12. 4 times negative 1. And then that's all over c minus 2, 3c minus 1. Now we can subtract these two fractions because we have a common denominator. We're going to have a c minus 2 and a 3c minus 1 in the denominator. What about all this stuff in the numerator?
Subtract like terms.
What about the c squared there?
Stays.
It doesn't add with anything or subtract with anything, so it stays c squared. Negative 2c minus 12c
Negative 14c.
is negative 14c.
Minus 4. Oh, plus 4.
Minus a negative 4 is plus 4. All right. That's about as far as we go with that problem.
So, this is exactly what your homework's going to look like. It's going to be due next Tuesday. You have 1 week.